video, we're talking about combinations, a little bit different. So here, order does not matter. Order is not important, okay? And so here's the combination notation. We still have number of things that we're choosing from, n, and then how many choices we're actually making, r, okay? And so here what it looks like, here's the breakdown. The only difference is we have this little factorial out here. So that's our r, okay? So we're still going to subtract these two numbers and take the factorial of that, but then the denominator also has this 4 factorial, okay? And then so when you break this down, you have 4 factorial times 5 factorial at the bottom. Oh, here's a quick thing. This will never, like, you can never multiply those. I can't multiply 4 times 5, so 4 factorial times 5 factorial and get 20 factorial. Okay, that's not possible. Okay, it breaks down like this. Okay, and then these would cancel out, and then 4 times 3 is 12, right? So you can break down these a little bit. So 3 times 2 is 6, so that's 6 would break out with that 6, and then you have 4 and 1. Well, this 4 would break down this 8 to a 2, right? So then really you just have 9 times 2 times 7, which is not that bad, right? So 9 times 7 is 56. 56 times 2, or yeah, 56 times 2, right? Because these would cancel, that would cancel that, get a 2. Oh, it's 9 times 7, it's 63. 63 times 2 is 126. Okay, so we're good. Got to do my math right, okay? Or you can use this button on your calculator. I could type this on a calculator, but I need to make sure that this, when I do 9 factorial divided by, I need to put this 4 factorial in parentheses, okay? Just in case. And then you can hit enter and you get the 126. Or I can do this combination thing where I hit 9, I hit the combination button, which is just to the right. It's underneath the divided sign. So I have to hit shift divide, and it'll bring up the C like that, and then I can hit my correct number, which is 4, and that will also give me 126. Okay, so you can do it that way, either through A. So let's do an example. Again, we know this is a combination, so let's kind of look how this wording is, so we know when we don't know if it's if we don't need, or if we don't know it's a combination or permutation, we can read through it and understand what combinations kind of look like. Okay, so suppose that you choose 4 books to read on a summer vacation from the reading list of 12. So there we kind of know we're picking from a total of 12, so that's our N, and we're only choosing 4, so that's our R. So we know what our N and our R is, but we might not know if it's a combination, right? Combination means order does not matter. So does it matter if what book you read first, as long as you read all 4 of your books? Where here it doesn't matter, right? It doesn't matter if I read which ones, unless it's maybe like a series, right? Then maybe that order does kind of matter. Okay, if it's a series, you want to do orders 1, 2, 3, and 4. You know, but here, most likely the book's reading order is not going to matter as long as I read the 4 books. Okay, so this is a combination because order doesn't matter. So I can do 12, choose 4. Okay, I can do it like that, and then I'll just go ahead and do the combination out, the notation. So the 4 goes here, 4 factorial, and then inside here I take 12 minus 4, and then I take the factorial. So 12 factorial on top, 4 on the outside of this, and then on the inside would be 12 minus 4 is 8, right? So 8 factorial. So then it breaks down, 12 is 12 times 11 times 10 times 9 times 8, and then times all the way down to 1, right? 4 factorial is 4 times 3 times 2 times 1. Again, you don't really even have to write the ones, right? Because timesing by 1 is itself, right? And then 8 factorial will be 8 down to 1. So these would cancel out, right? Both 8 down to 1s would cancel out. And then I can break down, let's see, I have 10, don't quite have an 8, right? So I'm just trying to mix these, like 4 and 3 is 12, so I can cancel out with that 12. 2 and 10 would cancel, right? Till 5, so then really I just have 11 times 5, because sometimes you might be able to do these without a calculator, right? And then I can just do that. I still can't do that in my head. 45, what is it, just 45 times 10 would be 450, and then if I add just another 45, so really 495, so this is 495. There's how many possible ways I can write this book. Again, I can type that in my calculator. I can do, I'm choosing from 12. I'm choosing where the order is a monitor, so it's combination, and 4. So I'm doing this. I'm typing exactly that in my calculator. And I get 495. Yay, I did multiplication without a calculator. I'm so happy. And then you can go ahead and do this. So as you read this question, Service Club has 8 freshmen, and 5 of them are to be on a cleanup crew. Okay. How many different ways? Well, you're choosing from 8, right? So there's your N. And how many you're actually picking from those 8? 5, right? So that's your R. Now is it a combination? We already know it's a combination because that's the title of this problem. But does the order matter? Does it matter if Greg is picked first rather than Amaya? Okay, or if Connor's picked first and then Amaya and then Greg, right? Do you know where that comes from? You know what show that's off of? Connor, Amaya, and Greg, huh? Do you? Do you? We'll see. Okay, so then you can figure out what's possible different ways. So you have your N, you have your R. Go for it. All right, two more problems after this. Okay.